So this is ixlEE13 find Z values. I'm a little rusty on this. I haven't done it in probably 2 years, but I don't remember it being hard, so we'll go with it. If you're using a new faceplate, Color Edition TI-84, the ones I have in my room, these are really, really easy. It should be anyways. Like I said, I haven't done it in a while. If you're using an older faceplate, come find me and I'll show you how to use it. You have to think a little bit with the older faceplates, which, you know, for most people is a big issue. Thinking is hard, right? You're going to use a function called inverse norm. The inverse norm takes the area under the bell curve and returns what's called a z-score. Z-score is nothing more than a standardized, or a, let's say, unit. It's where you take standard deviation, you get it down to 1 unit, as opposed to being 12 or 13 standard deviations. It's like 1.5 standard deviations. But we're going to use a function called inverse norm. Now, this is the bottom 20%, and notice that we have shaded the left tail. We call it a tail. We've shaded the left tail. And we want the bottom 20%. That means that this has an area equal to 0.2. It's 20% of the graph. Area is 0.2. So we're going to fire up our TI-84 Color Edition. Oh, other things I need to talk about. Since this is a normal bell curve, see it says standard normal? It has a mean of 0 and a standard deviation of 1. I think that about covers it. I really do. So now we can use that inverse norm function. We're going to go to second vars. And we're going to find inverse norm. That's the big thing. So, you know, check your faceplate. Second vars, it's right underneath that left arrow. It's where it's at. And just scroll on down to inverse norm. So the area on this particular example was 0.2. Mean is 0. That little guy right there is the symbolism for standard deviation. This little guy right here, he's standard deviation. And it was a left tail. So I'm going to go to paste, enter. There's my answer. They want this on IXL to the 1,000th, so negative 0.842. I believe they wanted the thousands. Negative 0.842. Yeah, they want the thousands. Negative 0.842. And then I hit the old submit button. Excellent, Milbrath. Here's another left tail, so I'll do another left tail with you. This is the bottom 80. So back to inverse norm, second vars, inverse norm, bottom 80, area is 0.8. It was still a left tail deal. Enter, enter. 0.842 is my answer. Notice the symmetry in those two things? It's there. Think about that if you think you're good at math. If you think. All right, we have a right tail. So what's new about this one? This is a right tail. That's really about the only difference. I say it's a right tail because I know the difference between left and right. It's on the right. There's some kids that make it to Algebra 2 who still don't have any idea what left and right is. They look at their hands and they're like, oh yeah, I write with this one. Whatever. Whatever. I'm being sarcastic, kids, I think. Second vars, inverse norm. Change the area to, whoops, I'm having a little slow this morning. Top 80. So, like my previous example, the area is going to stay 0.8, but the difference is I am a right tail. So I just changed that little guy to right. and I go to paste. There you go, negative 0.842. That doesn't seem right. That should be a positive. Oh, top 80. No, it's negative because we're going to be greater than that value. So this guy is on the negative territory. This right here in the middle would be 0. So that makes sense. And notice they have the greater than symbol, negative 0.842. Still doing good. Top 23, still a right tail. That's the big deal. And I want to use the decimal 0.23. Second bars. I could go back and edit my previous line, save just a tad bit of time, but it's not going to kill you to just keep typing this stuff in. Still a right tail. 0.739 is my answer. 0.739. Brilliant. I'm going to jump ahead because we need to see some centering stuff. The middle 50. Notice that. The middle 50. We're going to do what's called a center. There's no middle option. We're going to do a center. 50% being 0.5. That's about it. And you're going to get a left boundary and a right boundary returned to you. See, there's two blanks there. Second, vars, inverse norm. The area here was the middle 50, so 0.5. That's the same. And we have a center. Enter. Paste. And there's your two values. It returns it to you. It's got the brackets there. You've got something on the left at negative 0.674. On the right, you've got the positive 0.674. We used to teach this a little bit harder. We'd actually use tables and stuff, but you know, you guys have it easy and think it's hard. Negative 0.674 on the left, positive 0.674 on the right. Part of me hopes you're not doing this too soon so that you can remember it for your EOC, but it's really easy. Here's the middle 60. We're going to have symmetry too on these points because these guys right here are the same distance from the middle. So one of them is going to be negative and one of them is going to be positive. There's symmetry. Anyways, where was I? Forgetting what I'm doing. Middle 60. Second, vars, inverse norm, middle 60, 0.6. Everything else stays the same. Paste, enter. So here we're this negative 0.842 and positive 0.842. One thing I don't like about ixL is the constant repetition they do. I cannot stand it. Don't you be doing ixL and thinking you're good at stuff. It's just too blasted easy. Middle 30, that's not going to be a problem. Jump ahead, see if there's anything interesting in here. Middle 30, same blasted thing. Middle 88 is as high as it gets. So let's take this one out to a 95 because it's pretty easy. And that does it for ixLEE13.